high rises are springing up left, right, and center. And as facility managers, we need to appreciate, expand our knowledge and our ability to manage facilities that are vertically inclined. If you take Lagos as an example, you'll find out that more and more of the buildings coming up are going up, really going up. And there's a huge difference between managing a sprawling city, residential, commercial, industrial, whatever sector facility that is sprawling and spread out, um, less than a few floors, less than 4 or 5 floors and below, compared to managing facilities that are rising to 10, 20, 30, 40 floors above the ground. As facility managers, we cannot use the same set of tools, skills, abilities that we use in managing sprawling cities and developments to manage high rise. So today we're looking at these high rise. Why is high rise becoming the most common form of construction, and why it's important for us to adjust how we manage facilities, reorient ourselves on how to become experts and champions of managing facilities that rise above ground. So that's what we're going to be talking about in today's session. And I would just like to remind us that the graduation of the 2025 class is taking place on Saturday, this Saturday at Unila campus. So if you have not indicated interest in experiencing this graduation, I think it's something you shouldn't miss. We usually have a lot of fun, we celebrate, and we predict, the future. We point you in a direction to start thinking about how to take your career, move your career forward. Because if you are aware, if you are there where discussions of how FM is going is being discussed, you will take the right decisions to move yourself in the direction that will put you ahead of the curve. So Saturday is not a time to miss. We start exactly 9 for registration and red carpets, and then 10 sharp for the ceremony proper. Ceremony will last for about 3 hours. Then we'll have a break during the afternoon and return in the evening by 5 p.m. for a massive party, hangout. The alumni is putting together a very, very exciting end of the year party, which you're all invited. So it's all in the spirit of facility management, moving our careers forward, leading the industry, and making the right impact on the rising generation of facility managers. So it's something you shouldn't miss. With regards to our FM Mastercraft diploma starting on the 12th of January, you still have a few days to enjoy the 10% discount. So if you know someone or yourself who's looking for a foot in the door into facility management, advancement within the career of facility management, growth in the industry, you want to take advantage of this network that we have built for facility management in Africa, the best opportunity you have now to make that move with a 10% discount is by registering now. So between now and 20th of December, you still have a chance of registering for 10% discount. So we have that running, and we encourage you to take advantage of it. Okay, so get back into today's session, the future of vertical cities, implications for FM. Buildings are rising higher, and we should manage smarter. The FM that is going to be relevant in tomorrow's landscapes and the relevance in the industry is the one that knows how to manage high-rise buildings. because more and more of the low buildings are going to be put down. They're going to be pulled down and high rises built in their state. And it's pure economic sense. It makes a lot of economic and technological sense. We'll be talking about some of these reasons why you should look forward to highly advanced buildings, buildings that are rising above ground. So in this session, you would understand how vertical city design shapes facility management requirements. You identify the unique operational challenges of high-rise and mega-tall buildings, how to apply smart technology and data analytics to improve FM efficiency. You have to evaluate sustainability strategies tailored for vertical environments, and then strengthen risk, safety, and emergency management for high-density structures. We're also going to look at how to enhance occupant experience through optimized vertical mobility and space planning, and then develop future-ready FM skills for managing technologically advanced buildings. It's quite a lot to cover in 1 hour, so I'll be emphasizing some very salient points and running you through the others. So what defines a vertical city? It's high density, which means more people are packed into a small land area. Just last week, we saw in the news a fire that broke out in a residential apartment in Hong Kong. There were 4,000 dwellers in that single building. That's what we're talking about. If you build an estate with 200 buildings, it would make a city already if they are all built in bungalows. So when you use the space of 1 or 2 bungalows to build 200 units of dwelling spaces, then you have packed people, very densely packed together. But then you are creating space on top of each other to stack them up. So the multi-level urban developments helps to maximize land use by building upwards instead of outwards. It also enables us to integrate mixed-use spaces, residential, commercial, leisure, and services. So high-rise facilities also enables us to build mixed-use spaces, residential, commercial, leisure, and services, stacked within a single vertical ecosystem. So you could live in some floors as your residence, work in some floors as your offices and business places, go down to some retail malls and food courts. There'll be some, hotels, hospitals, all kinds of facilities, all arranged in that vertical space. And to make this feasible, there has to be advanced vertical mobility systems. So elevators that move people through the floors, high speed, they help you to get from one floor to the other in no time. And then you need to have self-sustaining infrastructure such as energy systems, water management, website processes, and green technologies embedded into the building. So what it simply means is that your infrastructure and utilities are all integrated. and to ensure that the managers of such spaces have visibility into what's actually happening within the facility. You must have digital systems and smart technologies. So we're going to be talking about how to enable real-time monitoring, removing human errors through automation, and ensuring that there is seamless facility operations. They really need to talk so much about why this vertical development is being forced on us by urban density. There's been a mass migration from rural areas to urban centers. The land sizes of the urban centers are not going to expand because more people have come in. So that's the major driver. Land availability is limited. And so why don't we use the spaces above the land and create multiple land, levels above so we can accommodate these migratory, populations that are coming into the cities. And as urban cities expand and increase in numbers, workplaces have to match. In fact, it's the existence of workplaces as is one of the major drivers of people moving from rural to urban areas. And then other amenities to take care of this population, hospitals, schools, police stations, and all that will have to be built as well. And so we see ourselves being concentrated massively in these urban centers. And so we just have to find ways, to build in such a way that we can stack people up for all kinds of activities and use of vertical spaces. And then another consideration is the lands available in urban centers become more expensive. So you really can't afford to buy a land now in Ikoyi or in VI or in Lekki Phase 1 for several billions of naira and build just a bungalow or something on it that will not give you the kind of returns for the investment on the land. So you have to build something higher. So that's something that is pushing it. There's also the fact that we want to be sustainable. We don't want to build clusters to the point where we no longer have green areas, we no longer have livable spaces. And so certain aspects or certain parts of the available land still have to be reserved for parks and gardens, orchards and trees and all that, just to ensure that there is a semblance of life living for those who are in these urban centers. And so vertical cities is the solution. But then the complication starts. If you have 500 buildings in an estate and there is an emergency, the emergency will probably be in one corner or one center or one spot or one building or the other. And people, will easily find their way out to a muster point and to safety from different parts of the land. But if you have all of that, those 500 buildings stacked up in one 30 or 40 story high rise, then what you have done is create a stack up of people, and then the exits are still going to be at the bottom. Everybody have to find their way to that bottom to exit the building. So it becomes a huge safety risk. So when it comes to evacuation, emergency response, you have a very, very complex, situation to deal with. Very recently, we saw horrifying videos of people trying to jump off many floors, to safety, and many to their deaths during the fire that broke out at the UBA house in Marina. We don't pray for such occurrence to happen again. But then we have to just face the reality that there should be forward proactive thinking on how high rises are used. Their height and density increase evacuation time, requiring advanced planning and multi-layered escape routes. And so the fire systems that are built into these high-rise should be very, very advanced. Pressurized stairwells, refuge floors, and intelligent alarms. Alarms that can sound across the entire building to give early disaster warning to people, even, if it's just a minor, occurrence in one part of the building. In this particular case, there was some uh, uh, power storage systems, inverter and batteries that overheated and started smoldering and fire. And so at that point, there should have been a lot of advance warning for everybody across the building, and action to activate that emergency response should have been well ahead. And so that's one of the things that it creates. Safety is a big issue. And then you have the emergency responders. If you call fire a team to an estate that's sprawling, they can drive in through, get to where they want to do the work, and then put out the fire. But when they come to a high rise, first they access to a certain point, they hook up, and then you now need very complex lifting equipment to get to higher floors. And if the fire authorities don't have that level of sophistication, and the building itself doesn't have those things built into them, like sprinkler systems that can automatically shoot out and spray on the facade, and then those that are inside that can pull out a lot of fire control liquids or whatever, foam or whatever solution has been built in and pressurized into that system, then we have a big problem in our hands. When you look at the high-rise buildings, it's not really optional that you don't want to use certain complex mechanical system, air conditioning, water, energy distribution. They're very complex. You have safety devices built in at different points. You have valves and controls built in at different points, and then you just have to be able to see what's happening to everyone. For example, when water is flowing, pumps are involved. When energy is flowing, transformers, switches, and so on. And some of these things can go into heating mode. Start having humidity in some spaces, and so on and so forth. And because you really can't take water, for example, you can't just put a tank somewhere and then the water will flow into all the building by gravity. There will have to be pumps steadily pumping the water at every point when you open a valve or faucet. If you have digital systems built in, like BIM, building information modeling, and digital twins that help you to immediately share advanced, detailed information with responders, it will help in their approach to the building to solve any emergency they are there to intervene about. Let's talk about mechanical, electrical, and vertical transportation demands. High-rise buildings require robust MEP systems to support dense populations and multi-level operations. So you have all these rooms, people pouring out into the elevator lobbies to use the elevator. So the elevator is always working. The loads on the electrical system increases significantly. Every time you push that button and you go into an elevator, a massive motor activates to either lower you or take you up. And that moment that motor is activated, a strong draw of energy from your electrical or power supply takes place. And then the air conditioning system must handle greater pressure differentials, temperature zones, and air quality demands across many floors. So whether you are using the VRV, VRF systems or the chiller central cooling system, there will be refrigerant moving across distances, chilled water moving across distances, and air handling units blasting fans to circulate this air um, across distances. And then, of course, your lifts and elevators. So when you're looking for critical systems in a high rise, lift and elevators are one of the most critical systems. It's important that we now have a way to monitor all of this. It's no longer business as usual. If you have a 4 or 5 story building and you put a lift there, you probably won't even monitor how that lift works. But if you have a 40, 50 floor building, the elevators have to be monitored very closely, because even the slightest vibration or sound or temperature spike in any of its mechanism should trigger an action from you as a facility manager. So not being aware of such predictive data is not an excuse. You really can't say, oh, well, I wasn't aware until something happened. You need to be ahead of that predictive situation. And because all of the assets are interconnected, facility management has to be a very seriously coordinated effort. The equipment that are built into high-rise buildings are also very sophisticated. It's not something that anybody can just wake up and start managing. You need to have very deep knowledge of the systems that you are managing. And so picking technicians who have, for example, managed small systems, not sophisticated, and bringing them in there without giving them proper training is disaster waiting to happen. Because the mindset, the philosophy, the way of thinking has to be adjusted to the complexity of the environment you are bringing them into. So they may not come cheap. And as facility managers, we tend to work with client budgets, economic considerations when taking decisions around should we follow strictly the OEM recommended PPM schedule, requirements for oils and greases to be certain specification. Can we manage? Can we find a way to cut corners and still please the client's budget while getting our jobs done? When it comes to high-rise buildings, we can't. You really don't have that leverage because the risk becomes too high. The risk becomes too high. You need to be, you need to up your game to the point where you can do everything as recommended with precision in such facilities. Because at the end of the day, you are keeping records, and those records are going to vindicate you at the end of the day if something happens. If something happens and you have been strictly following the regimen of maintenance activities prescribed by the OEMs that supply them, then you will be free. But if you've played along, allowed some things not to be done, try to look for alternative cheap options, you're putting everybody's lives at risk. And that is not something that any system or government wants to excuse. So we don't want to be at that point where the investigations will now lead to indicting us for not being meticulous. We have a duty of care to protect the lives and the assets of investors in high-rise buildings. So let's talk about IoT, automation, and real-time monitoring. These IoT, Internet of Things sensors, are connected to virtually every aspect of the facility, from your lights to the devices that pick up ambient temperatures from all spaces, crawl spaces, electrical panels, humidity levels, because some of these things are not things that you can easily just observe because you are there. So humidity levels in crawl spaces, in open spaces, you need to pick them up because they affect the operating parameters of the equipment and assets you have installed. And then occupancy data. Are people in the building? How many people are in the building? How can you tell? How can you plan for their safety in case of an evacuation to ensure that nobody has been left behind and so on? So that's where Internet of Things sensors come in. There are so many sensors now. You can basically have a sensor for anything up to the carbon gas content and different types of emissions you have within the spaces. Because some of these emissions come as a result of certain mechanical interactions within the spaces that if you don't check it, they become hazardous to the individuals, while that equipment that is emitting them is also going under. And then when you have automations, if you have those sensors and they are feeding those data into a mainframe server or an interface dashboard, you want to build in automations that makes those signals useful real time, not for you to read what the sensors are saying and then figure out what actions to take. Well, what automation does is that I can connect those sensor data to automated switches, controllers, gears, dampers, within the building, so that when the oxygen level is too low, automatic triggers to open a damper, for example, allow fresh air in. When the occupancy says there's nobody here, automatic trigger to switch off the lights. The person who is leaving does not need to remember to switch off the light. Just knows that the building just knows that the person has left, and then the light goes up. Same goes for your air conditioning. Air conditioners tend to work at same pace, irrespective of number of people who are in spaces. But when you now have humidity and temperature sensors, occupancy, they're all working together. They control the level of refrigeration activity, the cooling and condensing activities of the air conditioning. These are all automations that helps to reduce energy consumption. They help to increase comfort, of the end users. They work to extend the life of the assets by preventing any overwork or any excessive wear and tear. And also they are massive in energy cost reduction. So you have your facility now optimized because of these automations that are built in. Before now, if you needed an automation built into your high rise, you deploy a building management system, you deploy all kinds of sensors interconnected to a mainframe computer, and then you have visibility into all of this. And the cost used to be very high, but now you can deploy smart sockets and smart switches that can be integrated into an application like ThingsBoard or Home Assistant. You can deploy sensors, stick them all over the place, and most of them are even wireless, so that you don't have to run complex wiring across the facility. And once you install them all over the place, you can now have visibility from a central interface. Once they're all integrated, you can see what is happening across your facility. You can actually manage facilities without being there. And then for the energy efficiency we talked about, you can monitor consumption of energy to the smallest units. You can tell how much a laptop as small as this is consuming, because the socket that the laptop is plugged into is a smart socket. It has automatic controls that can go off and on. It has metering functionality that can tell how many watts or amperage I'm consuming as I'm plugged into it. I can see for every light, for every air conditioning, for every water dispenser, printer, server that I install, I can see exactly what each one is consuming. You know that time when you want to do some analysis, compare assets, life cycle cost analysis, and you are trying to project energy costs for that asset going forward, you can have a lot of data generated from your existing systems if you can have smart technology built into it. And so when we start talking about sustainability, when organizations mature to that point where they've moved from basic survival through they've moved from basic survival through You move from basic survival through resilience and then sustainability, and you're moving into smart. You now need to have data with which you can show that you are becoming more and more sustainable. You now need to have um, data to show how you are reducing your water use, your energy use, your material resources, how you are reducing their use and reducing your global your footprint or carbon footprint on the environment. All of this just comes because you've developed a network of smart systems through digitization in your facility. High population density also increases demand on water supply, energy distribution, and waste processing systems. Because we don't have so much space, we don't have that space to put in equipment, treatment plants, sewage plants, all over the land. They have to now be integrated. They will still do the same work for a very complex number of people, because if you have 5,000 people in one building, they will still, the waste refuse will be the same volume, the sewage will be the same volume, cooling requirement, water use, energy use, it still be the same, but then you now have limited space to pack all this infrastructure in the basement and certain floors within the building. And as facilities are, as people are more concentrated in that little space, that's how at certain times you have a huge spike in energy demand. For example, in the morning, people are getting ready to go to work. You see that massive spike. You have to account for it. You have to provide for it in the design and deployment of transformers and generators, for example. And then you see the lows. You can actually predict and negotiate for energy purchase deals using the highs and lows of these densely populated infrastructure of system that we built into the high-rise buildings. They also give us the advantage of easy certifications. If you want to certify an estate that is sprawling, you have to go building by building. There's all that thermal influence, there's water penetration, there is all kinds of interactions. But for a high rise, you could have that compact facility with all the data and sensors already built into it, easily establish itself as a low carbon facility, because it is the intensity that is measured, energy use per person, water use per person, waste generated per person, because you can easily control and reduce through these complex systems you built in. You can have the data to prove certification, and that's always the big win for developers, facility managers, and those who are managing such prospect, because once you're able to get those green certifications, it's easy to charge a premium. Your end users tend to have low costs. There's a prestige for living or working in such an environment where there is a high level of sustainability accreditation or certification, which is something that gives you both short-term and long-term value as a subscriber, owner, or tenants in such a place. And then there's the issue of climate change, environmental impact, risk related to those. Flooding, wind loads, extreme weather events like storms. Every time you experience such climatic occurrence for a high rise, the impact is often devastating, because there are many people. They're just sitting ducks in a tower, stuck in there. If you don't account for these in the design of the structure, design of the facade, design of the systems built into it, we'll be creating a lot of problem. So emergency preparedness plans for evacuation, backup power, and critical system continuity are very key for managing high-rise development. And that's why we must build in redundancy, which means we must have a policy of all that we need plus one, for example, for electricity, for water, because if there's a disruption, imagine if you suddenly go out, a certain pump goes out, and water could not be pumped, through your 25 or 30 floors building. Imagine what that would mean for the thousands of people who can't use the toilet, who can cook their meals, or who can do it just makes the building useless just because one pump goes out. So you must have multiple pumps interconnected in such a way that if one fails, all you need to do is switch over to the next one, and even automate that process so that there's always consistent supply of water. Same thing goes for air conditioning and electricity to ensure that the spaces are useful round the clock. Then there's the issue of indoor environment. Now people are being packed into a small, compact space, and any little emission of, any kind of noxious gas, or whether organic or inorganic effluent, exposes a very large number of people to risk. Okay, so the air quality inside has to be tightly monitored. There's always going to be sensors for picking up what the ambient temperature, ambient air quality is, so that fresh air can be allowed in every now and then. The reason you don't just open a high rise up for all kinds of air to be moving in freely, of course, that should have made it as healthy as possible, is because of the energy consumption of the air conditioning system. You want to make the system as close as possible so that temperature can be preserved, whether cold or hot, depending on the region of the world where you are, right? But because that can create a situation where we use up the oxygen and we now begin to have issues with air quality, we need to have a controlled means of bringing in fresh air. Then there's the issue of lighting as well. Being able to use daylight as much as possible increase the well-being of people using the building. And then there's the issue of noise control as well, right? Acoustic design, reduce stress and improve focus in vertical spaces. If you are stuck between two neighbors who are just wall to wall with you, you don't want to have to live their lives and the noise they generate in their apartment. So the walls have to be built in the way that there will be no interference. And then we also think about the materials we use, the furniture we bring in, the paints we use, the glues we use, the fuels we use within such spaces, because all forms of emission they'll create a problem for indoor air quality. These pollutants can be a big problem, especially for environments where you have carpets. Have to air the place properly for long to ensure that the pollutants, benzene chemicals are able to be extracted. And then people living in high rises should try and practice wellness programs. Go out as often as possible. Use the gym, use the pool, and ensure that they are well, because it can feel confining and restrictive when you are in such compact environments. And when you are in stacked environment, it's important that you form some kind of community, encourage social cohesion, because the isolation, if you stay isolated in one little box within that high rise with so many people around you that you can't talk to or interact with, it makes you unwell. It makes you, unable to feel free or feel healthy in the environment. So that interaction needs to be created. So we need to create social spaces, lounges, gyms, work areas, swimming pools, just basically encourage people to come out and interact one with another. Now, this issue of security, access control and security for high rise. If you expose a high rise to a security threat, it's one strike too many people involved, right? So you need to have complex access points across floors and zones, which require layers of security protocols and identity verification. So you have card systems for accessing elevators, for opening certain doors, ensuring that visitors have access only to the floor they have been booked for. You give them a card to ensure they can't just mill around the whole place and create nuisance. Real-time communication between security teams for rapid response to incidents, balancing security with occupant convenience and privacy to maintain a functional and welcome environment. Because you have more people packed into one building, you need to have more thorough threat analysis and mitigation. And the type of hazards and vulnerabilities unique to densely populated vertical environments. Conduct scenario planning for emergencies such as fire, power outages, or security breaches. Implement layered mitigation strategies, including alarms, evacuation routes, and redundant systems. Leverage real-time monitoring and predictive analytics to anticipate and respond to risk proactively. Train staff and occupants on safety protocols, emergency procedures, and threat awareness. One person's negligence, nonchalance, or ignorance of security procedures and protocols can expose too many people to a risk that we don't want to be happening on our watch. Same applies for the fire safety. I've talked about this. The doors have to be fire rated, for example. If there's fire in one section, it should be able to hold that fire within that section for attention instead of allowing it to spread through the whole building. So the choice of materials for doors, windows, claddings in high-rise buildings should be fire resistant materials. Even paints nowadays are available for fire resistant paint materials. And then setting fire suppression systems built into the area. So you have FM 200 in some areas, you have fire extinguishers everywhere, you have hose reels, you have sprinklers built across the building, just to ensure that if something happens, it's not only contained, but it's brought down and mitigated as quickly as possible. And then the teams that are going to manage these tall buildings need to be specially trained. Sometimes when it's time to mobilize to manage a high-rise building, we tend to be in a hurry. We tend to just pick people off the streets and expect that they will learn on the job. We need to have structured training programs after going through rigorous recruitment procedures to ensure that they don't just know how to operate the equipment and assets, but they understand the working ideology or philosophy behind those equipment, so that they can take sharp, quick decisions in the case of emergency. They should understand why certain switches are in on position during rest and why certain are in off position during rest. They should understand the workings, the dynamics of every equipment they are managing and why they are told to do certain things. So you must go beyond this is a maintenance plan to take them through maintenance strategy, understand why those things that are in the plans are the way they are. And now with software, so if you have all of those sensors, you now have a computerized maintenance management system or computer-aided facility management system where all of that data comes into. You have automation set up that certain things are acting on their own, but the information is still coming into that dashboard. It gives you visibility, it gives you historical awareness, and also helps you to plan ahead to fine-tune certain settings in the building to ensure that you don't have any risk or things don't go out of control. Data-driven decision-making for complex vertical systems. Vertical cities generate massive operational data, enabling FM teams to understand system behavior and make informed decisions rather than relying on guesswork. So real-time data from lifts, power system, air conditioning system, sensors, that pick up all kinds of ambient parameters, control system that switch things on and off, reduce and increase based on information gotten from the sensors. They all put down a set of data for every activity, for every on off, for every switching activity, every control activity, there's a data. For every minute that passes, there's energy consumption data, there are sensor data. All of this helps us to see ahead of what's going to happen. So if you have equipment that are running at temperatures or energy use above their ratings, it is an indicator of a problem. So if you see such a thing, you want to step in and act before anything goes wrong. And then with all that data, now with AI, there can be automatic fine-tuning. AI automates routine FM tasks, enabling teams to focus on strategic decisions rather than manual monitoring or reactive problem solving. Intelligent algorithms analyze vast building data to predict equipment failures, optimize maintenance cycles, and reduce unexpected downtime. AI-powered systems continuously adjust HVAC, lighting, and utilities to boost energy efficiency and cut operational costs in real time. Smart assistants and chatbots support FM teams by streamlining work orders, enhancing communication, and improving service responsiveness. AI will enable more accurate forecasting, scenario modeling, and risk assessments to strengthen long-term planning and overall building performance. In the past, you have a software where you put in the asset data, and then you go pick up data from meters, and you put them into forms, you generate reports that you've manually entered. But now you can put in the asset data, connect the AI through API integration to handle designation of tasks to workmen through automatically scheduling tasks and creating work orders. And you can put in IoT-enabled controllers and sensors and insert the server credentials of the software into those sensors so that the data comes right into the software automatically. You don't have to go read and come and put in the data. And with AI being able to analyze all of that data that is coming in real time, you get advice on how to fine tune, how to reset, how to adjust. You'll get information on patterns and trends. So you know what has happened now. It can tell you this is what's going to happen next. You can use that information to make decisions on what to fix, what to repair, what to replace in the facilities. And then, of course, our most common work is inspections, right? And maintenance activities. Now we can get support from AI-driven devices and systems, robots, drones, AI-enabled devices. They can conduct routine inspections, spot issues early without disrupting operations. For example, vibrations. A pump can be vibrating and you've seen the pump. The next level had not gone too much, but the vibrations can lead to a belt cutting or a pulley coming off out of position. With technology, that vibration can be picked up and analyzed against the previous ratings or readings that have been acquired, analyzed against what is going to happen next, and it can tell you in the next few hours you're going to have issues with this pump. So you don't run out. Nothing comes to you anymore as a surprise when you are adopted a significant investment in technology. And the cost to deploy technology compared to the risk that you are having to have so many people packed into one building, I would say go for that technology, go for that way to know, go for that automation. That investment is always going to be worth its weight in gold when done right. And then high-rise buildings cannot be in isolation. If you put up a high-rise building today and you expect to connect to the grid, the national grid, for example, you have to have collaborative planning with the distribution companies to ensure that adequate, preparation can be made to, give you enough power. And they have to be ready to expand their systems run new lines. For example, you need a 3 kVA line to your facility from a distance, that did not thought of implementing because of your siting that facility. They have to make such investment. They want to serve you, but you have to give them information. They have to be able to plan to be able to serve you right. Facility managers collaborate with city planners and regulators to ensure buildings align with broader urban development goals and long-term master plans. And that's why you must also get approvals. The approval is not just for, I'm building this type of building, it's going to be this tall and this big. It's for everything, including the purpose of the building, kind of people you're going to have in there, how many of them are going to be in there, what are they going to do in that building. The government have to go through every of those information and items before you can get approval. Strong public-private partnerships help FM teams navigate zoning requirements, density limits, and vertical infrastructure regulation. Sometimes you've built, a high-rise, and you've told the authorities it's going to accommodate 5,000 people, and then you don't have any occupancy limit controls in the estate ordinance or the lease agreements you give to tenants. People start using it for hostels and using it for all kinds of high density activities that almost doubles the number of people that should be using that facility. You're not only creating a problem for yourself in terms of providing for all of that, the amenities, the utilities, and the requirements to protect and safeguard them. You're also putting pressure on municipal facilities, drainages, energy from the discos, sewage, and all of that can become a big problem because of how you are populating the facility. So all of that information must be shared and collaboratively planned with, so that everything can be done in such a way that everybody can be happy. If you put several high rises in the street that only had low-rise buildings before, the drainages have to be redone, for example. The roads have to be redone. The power lines have to be replaced. If there are going to be, communal facilities, sports centers, and clinics and police stations, it has to change because you now have to accommodate this increase that you are bringing to the environment. So as facility managers, we must think, very deeply and widely and out of the box whenever we have a high rise in our hands to manage, starting with the technological complexity, to the sustainability requirements, to the risk and safety requirements, to the municipal infrastructure impact, and how we can plan with the local authorities to ensure seamless integration. It's all a lot of work, and we must do it in a cool-headed, approach if we want to get the best results. Okay, so that's our session for today. I hope we're able to get 1 or 2 points. For those who are not yet managing high-rise facilities, I would say there's a lot to learn. So take advantage of opportunities like this, and more you can find on YouTube and other learning resources to increase your capacity to handle such opportunities when they come. And if you're already managing high-rise buildings or working in high-rise buildings, there's a lot to adopt, there's a lot to adjust. Otherwise, the risk will always be hanging over your head, and we don't want that to turn into a major disaster. So thank you everyone for being here. I know some of you might have questions. Because of time, I would say put the questions in the group, the facility management training group on WhatsApp, and Max-Migold business and training on Telegram. Also on Facebook, we are also there, Max-Migold business and training, and we have LinkedIn, Facebook, YouTube, and X accounts, so you can contact and interact with us, and we'll keep responding to your questions. Don't forget the FM Mastercraft Class of 2025 graduation host this Saturday at the Nigerian Society of Engineering hall in Unilag, just beside Works departments in Unilag campus. 10 a.m. sharp, the event will start. And our next session of the FMMC Mastercraft Diploma holds starts on the 12th of January. please spread the word to your friends, to your family, to your colleagues, and let them join now. We still have 10% discount running to the 20th of December. Thank you everyone for being here. Have a good rest of the week, rest of the day, and see you next week, Thursday.
Thank you very much, sir. See you on Saturday.
Thank you, sir.
Thank you. Thank you, Isaac. Thank you, guys. Awesome. See you on Saturday, everyone. And bye for now.
Thank you. Bye. Bye, everyone. Bye.
Thank you, sir. Bye.
Thank you so much, sir. Bye-bye.